All right, welcome. It's so exciting to be here today. We're going to have a great virtual meetup. Uh, Very excited to see the world of data. I know this past month there's been all these great breakthroughs, a lot of changes, a lot of dynamicism we're seeing with the modern data stack. In just a couple minutes, we're going to get started with today's meetup. We're going to focus on some exciting topics about the modern data stack and how it relates particularly to SingleStore. As you're tuning in, whether it's live or on repeat, we're just getting started. And I'll be guiding you through some interesting technology, some distributed technology, which is very exciting today. As we're getting started, I'll let you know a little bit about myself, and then we'll dive into this session as well. So my name is David Yakobovitch, and I'm an education delivery specialist here at SingleStore. And as we're living in this hybrid world and we're bringing everyone back together in real life, in virtual and hybrid experiences, we're launching meetups. And the meetups are starting as virtual. We'll be going back to in real life and hybrid as well soon. And today's meetup is virtual from our Raleigh, North Carolina office, and I'll be giving us a great discussion about distributed SQL or SQL systems. We'll be taking your questions as well. You can share those live, whether you're joining us on Twitter Spaces, LinkedIn Live, or YouTube Live. The session will also be hands-on. We'll be coding, so you'll be able to work directly with our SingleStore Managed Service cloud environment. And for those of you who code live with us, there are prizes today in addition to our standard $500 of free credit to work with the managed service. You'll be entered into a drawing to win one of three Amazon $25 gift cards. So if you spin up a managed service cluster today and participate in our live questions, our Q&A, as well as the code, you'll get the chance to win one of those three Amazon $25 gift cards. Well, let's continue now. We're going to get started on the topics of today, which is focused on a primer on distributed SQL systems. As you have questions, you can share them anytime in the chat. We'll be standing by for all of that Q&A. So today's topic, we're going to focus on architecture of distributed systems like SingleStore, as well as these technology known as aggregators, leaf nodes, and partitions. We'll dive into shard keys and how that is unique for distributed SQL systems. As you're learning on SingleStore, you can learn your way through a variety of options, including our documentation at docs.singlestore.com, both for the managed service and self-managed versions. You can engage with peers on our forums, learn on YouTube, as well as learn through our training at training.singlestore.com. You could also learn from our knowledge base at support.singlestore.com, which has over 200 articles on leading questions from our startup, scale-up, and enterprise partners. And as well, you can get $500 in credits today for spinning up your own SingleStore managed service clusters. This is through the link singlestore.com/managed service trial. Feel free to sign up today. You could sign up with your email, with Google accounts, or through the Microsoft authentication as well. A little bit about SingleStore before we dive into today's topic. SingleStore is the single database for data-intensive applications. If you're working with transactions or if you're working with analytics, SingleStore can solve for both use cases. In fact, SingleStore is HTAP. It's a hybrid transaction and analytical processing ecosystem that includes data structures such as relational, geospatial, full text, key value pairs, JSON, and time series. In fact, SingleStore has today universal storage, which is our patented technology blending both Rowstores and column store structures, the in-memory data and the on-disk data together. SingleStore is the industry's first cloud database built for data intensive applications. That means scalable and relational SQL, unified data, and optimized for data intensity. All of our systems can run in real time, and we have Fortune 500 companies from the Ubers and the Hulus of the world who live with SingleStore each day, building systems that are better together. SingleStore truly runs anywhere. It runs self managed on premise. We have a managed database as a service option, a hybrid option for the cloud and multi cloud, self hosted cloud on a specific cloud such as AWS, GCP, or Azure, and containers where you can run Kates out of the box for container as a service. Now we'll dive into our first part on the single store architecture. We're going to move into this topic talking about what makes single store distributed technology unique. We'll look at aggregators, leaf nodes, and the partitions so you can see under the hood about the single store engine. Let's dive in. First, SingleStore has a command plane for its cloud cluster. As a cloud first system, SingleStore's aggregators help you run all parts of your SQL queries. First, from the data definition language of creating your tables, that DDL is created from what's known as the Master Aggregator and can also be forwarded from child or secondary aggregators. In addition, the data manipulation language, DML, these commands can be run from directly on your master aggregator or your child aggregators, these secondary aggregators to distribute your workloads so that any of your queries are running in real time. And lastly, the command or the configuration manipulation language or CML can also be run from the cluster, from the master aggregator to manage your entire workflow. These aggregators are at the heart of the single store engine and the software that drives distributing your data across different nodes. So, what are nodes? SingleStore works through a client application, and that client application could be a web app, could be a dashboard, could be an API running either through a MySQL endpoint or through an HTTPI connector as well. When a request is made from this application, it is sent and routed to the master aggregator. That aggregator then decides how to optimize for the query. And depending on its complexity, will bring in the child aggregators as well, and then share that request to these nodes. And these nodes are your worker horses. They're solving for your requests in real time. And depending on the complexity of your data request, you may have a cloud first cluster that has 2 nodes, 4 nodes, 100 nodes, or even 1,000 to scale up for your systems. Once these nodes solve for your request, they're working with the data that's being housed on these leaf nodes, and they're computing or solving for the request. It's a distributed request. Imagine you have 100 of these leaf nodes. Well, that means 100th on average of your data is being solved for on each leaf node, which also means 100 times or faster you'll return a result back to the requester. Once those results are checksummed, validated, and shared back to an aggregator, it's then distributed. That entire result, it's summed up and brought back to your client. And in real time, your dashboard, your application, it's showing those results so that you can make those decisions that you need that are mission critical. Here's a high level overview of this architecture summed up. An all up architecture is where you have a master aggregator and a child aggregator. And those requests are distributed to these leaf nodes. In this scenario, there are 4 of those nodes, each with partitions. Each partition houses part of a database, and on each partition, there are multiple tables. In this scenario, there are 8 partitions per leaf node, and each table is also distributed. So, because there are in this scenario 32 partitions, on average, 1/32 of your data from each table is warehoused onto each partition. This is essential to distribute and to have as uniform as possible that distribution so that you can run your queries and solve with the same compute across each partition. That's part of the magic of SingleStore to build systems in real time by distributing and running parallel operations for your SQL queries. Let's dive into a knowledge check now about the architecture overview of distributed SQL systems. Your participation is required here, so we're going to run with a system called Poll Everywhere. And there's a few ways you can participate. You can go directly to the website pollev.com/DavidY075 to participate on this poll, or on your mobile device, you can text to the number 22333 the code DavidY075. And once you do that, you'll see this question and you can participate with the responses such as A, B, C, or D. This first question asks, what does the master aggregator do in a single store cluster? And there could be more than one response that is correct. So you can share your response and choose whether that's A, B, C, or D, or multiple of them. You can participate in this question directly from your browser at pollev.com/DavidY075 or by texting DavidY075 to 22333. I'll give everyone about 30 seconds if you'd like to participate on this poll. Okay, I see a couple results coming in. And let's take a look now and see what your responses were, and then what are the right or the best answers. Okay, so we have a variety of responses here. It looks like we have responses of choices A, C, and D. Looks like A comes in the highest. Let's see what is correct. All right, it looks like actually A, C, and D are all correct in this scenario. So the master aggregator, 1, it receives the queries from the requesters. Recall I was talking about those client applications, those requesters sending the queries and distributing the work. 2, then it returned those query results to the requester. After the middle step, it combined those results that will return from leaf nodes. So in this scenario, A, C, and D were all correct. Excellent work. Thanks for your participation. And as a reminder, participating on these questions and setting up the SingleStore Managed Service cluster will enter you into our Amazon gift card raffles today. Okay, let's now continue on to our second question. We now have a question on the leaf nodes. This question asks, what does the leaf nodes do in a single store cluster? I've unlocked this question, and you can run it from the same link, paulev.com/DavidY075, or texting DavidY075 to 22333. What does the leaf nodes in a single store cluster do? And could be more than one correct response as well. Oh, I see some great responses also coming in from Twitter Spaces, YouTube Live, and LinkedIn Live. You will want to share those responses directly through the Poll EV software, though that's great participation there. Thank you. Okay, we have quite a few responses coming in. So let's take a look at what those responses are and then see the correct response. All right, we got a variety of responses here. Looks like guesses, educated guesses on B, C, and D. Looks like C is winning out. So in fact, on this question, A is coming there too. Look at that, variety of responses. In this case, C and D, these are the correct ones. So C, what do these leaf nodes, these workhorses do, right? So first, they execute the queries. They're actually the compute engines where they're going to solve for your request. But two, they're also storing the data. They're not the only place data will store, because today SingleStore has a unique bottomless or unlimited storage technology, which is part of our three-tiered storage that we'll save for another meetup. Though this is one of the primary places where your data is stored so that you can run queries both in memory and on disk in real time. So great work on this question. So this has been our first core section on architecture. You've been seeing here about how to set up a cluster, how there are these master aggregators, these child aggregators, the secondary ones, and the leaf nodes. Now we're going to go into our second section today, which will be following up with some code. This section will be talking about sharding and shard keys, the distributed shard technology, which helps SingleStore be powerful as the database for all data-intensive applications. Let's dive into this sharding technology. So here is an aggregator. We talked earlier about master and child aggregators. The question becomes, how does the data transfer once this request is created on a table? So let's imagine you are this software developer, the data scientist, the ML engineer, or the DBA, and you've created tables, and you're ready to bring that data into the distributed engine where there are partitions housing all parts of your tables. When you create your table structure, this is where the distributed shard technology is at play. That table design ensures that your technology makes the data uniformly distribute to every partition on your leaf nodes. In this scenario, the data is uniformly distributed to 16 partitions. Now, there's the chance that it's not uniformly distributed. Now we see another scenario where the data has been moved into a different distribution. In fact, you'll notice how some of these partitions house more data than others. This isn't necessarily bad. It just means that the shard technology has created an uneven distribution as a result of the column that was being worked with. Perhaps that column didn't have an even split of this sort key, or this what's known as a column store sort key, or this shard key. There's multiple keys available on SingleStore. And regardless of the ones that you choose, again, today we're focusing on shard keys specifically, depending on the table structure will impact how that distribution occurs. And your goal as a developer is to create as uniform of a distribution so that all your queries, whether they're short running queries or long running queries, you're achieving your results in real time. When we take a step back from an overview, this is truly sharding in action. Let's say you have a scenario where you have a pipeline of data, and that pipeline is moving and transferring data onto the SingleStore database. When that data hits the SingleStore database wall, it's connecting directly to the aggregators. Once that data is fed in, SingleStore's hash algorithm, which is on the shard key column that you choose, will in real time distribute the data to these different leaf nodes. And then that data is available. New metadata is being developed. It's appearing in real time on these aggregators as they're listening in to the architecture and understanding the relationships of the locations of your entire data. Now, let's look at a scenario. Here is a table for orders. This could be real-time orders ahead of the holiday season. Many of us in the entire world recently celebrated Valentine's Day, right? So this is a big holiday where people celebrate the meaning of love, actually. And so at Valentine's Day, a lot of sales came in for flowers and chocolates and lots of great items. So let's say that this here is a table that talked about a holiday such as that. And you can see here that the order ID column was selected for the shard key. In this scenario, that order ID column is uniform. There's 16 data points, there's 16 partitions, and they're all unique numbers. So we have a uniform distribution, which will result in your queries solving as fast as possible with no delay. Let's say that in this scenario, instead, as a developer, you chose the customer ID column to be the shard key. Well, in that case, what would have happened would be, well, we can see here that some of these partitions, like the number 12, the numeric 4, the numeric 1, 2, and the numeric 9, housed more data than other partitions. In fact, numerics 0, 3, 8, 11, and 15 house no data. So what you would have in this scenario is you might run into a race condition where you're waiting on a partition like 12, and other ones are just sitting idly doing no work, which means you're paying for compute that you're not using. So it's to your advantage and your benefit to create a data structure schema that uses all of the partitions available. And that's part of our next thought on how do you create the best shard keys? What are those best practices? When you're thinking about creating shard keys, there's two goals to keep in mind. First, you want to have even distributed partitions with little skew. And to do that, you're thinking of choosing a shard key with high cardinality or high uniqueness, such as a primary key. Second, you'll want partitions gathered on records with a common particular field. If you're running queries very frequently on the same column, such as for a group by, an aggregation, a whereby, and you're continuing to run these queries, that may be an indicator that that column could be a shard key because you're frequently using it and you want to ensure that that data is evenly distributed. Now, not to worry if the distribution is not perfect. SingleStore's engine does create reference tables to join data together and distributed joins as well so that all your queries are optimized and tuned for the best possible query performance. Well, these are our two core sections we've started out with, and this is going to lead into our next interactive section where you can code along with me. This will require you to spin up a SingleStore Managed Service cluster. You can go to the singlestore.com/managed-service-trial link. When you go to that link, it will take you to a screen that looks like this, where you can sign up for SingleStore. You can either include your name and company email or sign up with Google or Microsoft. After you sign up, it will take you into our SingleStore customer portal. And for your first time, you might see some navigation recommending you to create a cloud or self managed version of the product. After that, it will take you to another view, if you refresh, where you can create your own database cluster. Now, I'm sharing for everyone this walkthrough to get you set up and powered up with SingleStore Managed Service. As a reminder for those of you today who follow along and in real time create your managed service cluster, you'll be entered into this raffle for one of 3 Amazon gift cards. So excited to get you working today with our database and powering your data intensive applications. Once your account is created, how do you create a cluster? It's as simple as clicking on either the Create Database Cluster purple button at the top right of your screen or the plus button at the top left of your screen by clusters. I'll create that plus button and I will be brought to a new navigation. This navigation, I can choose a cluster name. So I'll use my initials and then I'll give it some framing such as this meetup that I'm joining you all from in Raleigh. Then you can choose your cloud provider. We are available and cloud agnostic on AWS, GCP, and Azure. I'll choose AWS. And then a region. In this case, I'll choose North Virginia. I'm based on the East Coast, so this is nice and local to where I'm at. You can then choose the compute for your cluster. We have sizing available anywhere from S00, which works great for this lesson today, all the way through S32 and beyond. Now, we have clients who work even on S128, these massive clusters for running, for example, high frequency trading systems or managing on demand ride sharing or real time advertising serving or managing dashboards for supply chain optimization in real time. So there's a lot of great things that you can do for launching and scaling with as much storage and compute as you need with SingleStore. For today, we'll keep it with the S00 sizing. And then I'll press the next button. Now I can set an administrative password. I'll press generate strong password and copy that to my clipboard. And then I'll allow access to my specific IP only and press create cluster. That's it. It's a 2-step process. And now our SingleStore engine is creating this cluster. It's going to appear on the cloud, whichever one you chose, AWS, GCP, or Azure. And within a few minutes, it's available for you to code and start working with distributed SQL technology. Once your cluster's up and running, there's a couple ways you can connect. The most straightforward one that I'll share for today is notice on the left side of my screen, there's this query section. And that query section includes what's known as the SQL editor. That's where we're going to run today's lab from. So I'm going to click on that SQL editor. Now, the code that you're going to use today, I'd like to share that before I dive deeper into this code. Particularly, it's going to be at this link. We have here a bit.ly link. The bit.ly link is bit.ly/SingleStore 4. bit.ly/SingleStore 4. This will show the code that we're going to use on the cluster. There's 3 parts of this code. Part 1, you're going to create a database. To create the database of not exists for DB training. Part 2, you're going to use that database. And part 3, you're going to create a table that has a sort key on our column store, the data structure of choice in universal storage, and the shard key to distribute data. Super simple, just 3 steps. That's what we're going to run today. And let me demonstrate that for you. Once you click on the bit.ly SingleStore 4 link, this will redirect you to a GitHub page, a GitHub gist. And this has that code available for you. That link again is as simple as bit.ly/SingleStore4. And then it will redirect you to this GitHub gist where you'll have that code, which you can copy and paste to your copy and paste notepad so you can share it when you work on the SingleStore cluster. I'll navigate back to our portal and I can see that my cluster is almost up and running. Prior to today's meetup, I did set up a previous cluster so we could be here in real time together. And I'm looking forward for you to also run your code in your cluster as soon as it goes up. So my cluster's here. I'm going to paste that code I copied. And let me talk everyone through all 3 components here. So part 1, we're going to create the actual database. You can highlight code or run Control or Command Enter or the little purple button at the top right to run that code. So I'll run the first one and we're now creating the database. This is done instantly. If you see any lag, this is from your visual processor with your CPU or GPU in the browser that you're running with. Second, I'll choose to use that database. I can run that command here, and we'll notice that the Select Database dropdown changed to choose the DB training. And third, our final part here is to create the table. Let me talk through what you're seeing here in this SQL schema. On SingleStore, when you create a table, that table is, by default, a column store as part of our universal storage, which integrates in-memory row stores with on-disk column stores. The default as of SingleStore 7.1, so this is since early 2021, that default is column store. So when you choose to create table, we're creating the column store, this highly compressed data structure. And this one's representing balance. So think about high frequency trading. Maybe we have a hedge fund client here or a multinational bank that they're looking to manage the balances of private net worth clients. And that balance has a variety of columns, such as the balance in the US dollar denomination, a local currency if the client travels around the world, the date of transactions, their account, several IDs for the bank, currency, country, the company associated with that transaction, and that country as well. And then 2 additional unique features of SingleStore's distributed technology. The first one is the sort key. Today, although we focused on shard key, the sort key is unique for column stores. The sort key highly compresses your data, and that compression can be anywhere from, let's say, 20% to up to 80 or 90% compression on your data structure. We've seen clients go anywhere from having a table that could be 1 terabyte in size down to 200 gigabytes in size. Think about that scale reduction with the compression from SingleStore column stores. Now, your mileage will vary depending on how wide and sparse and the different data types available in your column store. Though there is significant storage savings and then compute savings by working with SingleStore's universal storage. In addition to the sort key, this is chosen on date because, well, transactions are run on a time series basis. So there's an easy way to highly compress our data there. Secondly, there's the shard key. And so shard key in this scenario was chosen as company ID. It was chosen as the company ID because perhaps this is a column that there are frequent transactions and there's enough uniformity among them so that when the data is distributed among these leaf nodes, it has a good uniform distribution with high cardinality. And that's this table here. You can highlight or run that command. And once you do that, you'll create this table and have it available for you now as a column store. Now, let's say that you wanted to unpack some further information about these tables. SingleStore does support a variety of commands available in our documentation known as the show commands, where you can see more about the schema, the memory, the data structures, and all this information from the information schema that you can unpack. Though, in addition to that, I mentioned there were two ways for you to access the SQL editor through our managed service cloud instance. The first one here is from that SQL editor on the left navigation. The second one, if you go directly to your cluster, which actually may be up now and live in real time, you can go to your cluster and go to the second navigation known as monitoring. Now, please note when you go there, you'll need to know that admin password. If you happen to forget it, not to worry, you can click reset, generate a new strong password, and instantly have that available. So this will be a second option for monitoring that we're going to access. It's not the only options. There's also this connect button at the top right, and this will share with you the CLI clients like MySQL, SingleStore endpoints, SQL IDEs, perhaps you work with Workbench or SQL Pro, applications and programming languages of your choice like Ruby on Rails, Node, or Python, and BI tools such as Looker, Tableau, and Power BI. So there's a variety of ways that you can connect to SingleStore. In this second scenario, I'll go to monitoring and click on the purple Open SingleStore Studio button. This will take you now to a new tab in your browser where you can paste your administrative password, press submit, and you'll connect directly into the monitoring view. This is special because you can, on the left navigation, click on databases and see your tables that were created. I'll click on the DB training database and I can see my balance table and all the parameters about it, including any indexes like my sort key or this column store key, as well as the shard key and the SQL code generation that the SingleStore engine adjusted when the table was created with its statistics. It's pretty cool. There's a lot of features to uncover, and this is just the beginning. We're peeling back the layers of the onion as you're learning about distributed SQL technology through SingleStore. As a reminder, that code was available on bit.ly/SingleStore4. As you're continuing to work with SingleStore, your journey is only beginning today. SingleStore is a cloud-first database, and we have another knowledge check here to reinforce what you've learned on sharding and shard keys. Here is our final knowledge check for today. And this question is, which of the following best describes what a shard key is? This one will only be one response or your best guess here. Let's all take a minute on this question. Okay, let's take another 30 seconds here. I see we have one response that's come in. All right, we got two responses here. Let's take a look. See what your third response. I love this real-time participation. Let's check it out here. Here's the responses. Okay, variety of responses here. So which one is the shard key? I know there's a lot of information that we covered here today. The best choice was the first option. It's a column that determines the partition where the data is stored. I think our throwaway guess was the second one, right? Column to segment data, but it's not only for column stores. It's also for row stores. It's for universal storage, all the technology. So I'd say the first one's our best choice. Thank you for your participation there. Let's now bring everything together, and then I'll open up for Q&A as well. So tying everything together from today's meetup on distributed SQL technology, SingleStore today is known as the database that is at the convergence of transaction and analytics. You may know transaction workloads on different databases and data warehouses. You may see different analytic workloads on different data lakes and different engines as well. SingleStore is building the best of both for operational databases and data warehouses. SingleStore also has best-in-class security and certification. The technology supports role-based access control. We have SOC 2, ISO 27001, and GDPR compliance, as well as encryption both at rest and on movement, on transfer. And as you're continuing your learning journey with SingleStore, you can go to docs.singlestore.com where we have all the SQL commands that you can learn. Everything from these show commands, create table commands, and working with everything such as user-defined functions, pipelines, anything in SingleStore SQL is available there. And SingleStore is over 99% compliant and compatible with the MySQL wire protocol also. Well, now we're going to open it up for Q&A. Happy to answer any questions that you have from what you've learned today. And I'll be available. We're going to go through any questions that you have. I like to make this interactive as well. A few other items I'll mention that as you continue your learning journey, one of my favorite places to go is training.singlestore.com. Training.singlestore.com is fantastic because our curriculum team is always adding new courses. Some of our most recent ones added included working with SingleStore with Python and Flask, working with SingleStore with C#, working with SingleStore with Node.js, as well as spinning up SingleStore clusters with K8s or Kubernetes. We have a whole entire segment on Kubernetes that's now available, which lets you deep dive into the K8s ecosystem and managing that for SingleStore, whether you're going to run that self-managed for a cluster or you're going to spin it up on AWS, GCP, or Azure with any of their container ecosystems. I'll also remind you that we have today the $500 in free credits for spinning up a SingleStore Managed Service cluster. That could be run again at singlestore.com/managed-service-trial. Okay, we have a question here in the chat. This one comes from us from LinkedIn Live. This question asks, how do I decide what shard key to use? So if you're creating a table today and you think about shard keys, there's no one size fits all. It's experimentation. Similar to data science, you might be trying different shard keys out. Your goal is looking at your queries, both the short run queries and the long run queries, and seeing as you run them, where are you getting performance improvements? And what is the average time these queries are taking to solve? So often I'll encourage developers to spin up a few different environments and create these different tables. You can either run them on different clusters that are in a development environment, or on one cluster, you could create different databases where you have multiple versions of the tables, and then you're seeing those results. Depends on what you need for data integrity and data persistence. So when you're thinking about creating these clusters, that's very important for your consideration. We have another question here coming in live. This question is asking about how easily can you integrate data tools such as SSIS when moving data from SQL Server. So if you're doing ETL. So SingleStore has a full built-in support for pipelines. So if you're going to transfer or move data from another data warehouse to SingleStore, I encourage you to check out SingleStore pipelines. Pipelines are fully working with Kafka, with Confluent, with Red Pandas, or any type of pipeline technology. So they're very helpful if you're looking to transfer technology, transfer that data, and move that into SingleStore. In addition, SingleStore also supports CDC. So we have this capture if you're going to move massive amounts of data from a legacy data store into SingleStore. Now, if you're looking not necessarily to move all the data, but to run, for example, with SSIS for your analytics and your information systems, there is support for any SQL connector. So if you have a SQL connector through SSIS, you can connect that directly to your SingleStore cluster. And I'll briefly show you where you can find all that information. So we're back here on my presentation, and I'm going to zoom out and go back to the SingleStore customer portal. And in this portal, I'll remind you at the top right, there's the Connect tab. And that Connect tab shows you where you can connect to these different clients. So we have, for example, SingleStore endpoints and the MySQL client, and any SQL IDE. So this would be similar to SSIS, right? You can choose this information, whether from SQL Pro, SQL Workbench, and connect it as well to SSIS. And then you're directly querying against the SingleStore database through your favorite tool. And if that's SSIS or another, SingleStore does fully support that. And we'd be happy to support you as you continue to integrate from any Microsoft products with the Azure stack with SingleStore. All right, a few other questions here coming in the chat. The next question here is asking about what's the difference between SingleStore and a Snowflake. So where Snowflake excels is it is a modern data warehouse. It's a modern data stack for housing and organizing data. And then you can run some good analytics. The challenge with an ecosystem like Snowflake is when you're working with transactions and pipelines, it doesn't excel as much. It's a little slower, and the total cost of ownership is higher. So often we see clients who augment Snowflake by running workloads on SingleStore, saving on the total cost of ownership, both the time to compute and time of cost. And that's the benefit that SingleStore is this hybrid transaction analytical processing ecosystem. In addition, when you think of Snowflake and how this data lake or data warehouse that's modern has so much data, often it's difficult to find out how do you fish for it? How do you discover that data? There's so much complexity. And on SingleStore, we simplify that, make it easier to separate storage and compute by the database and by the table so that you can access what you need when you need it. And that also helps reduce costs. We have a new feature where you can also suspend and resume your clusters. And by doing that, you can further save on your costs to ensure that mission critical queries only charge you for compute when you're using them. So I encourage you to give SingleStore a test drive. We've seen a lot of great results where clients have augmented their workloads from Snowflake with SingleStore. And depending on the scenarios, we've even seen companies who are running on multiple data products like Elasticsearch, Redis, and MongoDB. We actually have one client running on multiple of these data products who then consolidated and moved all their data productions to SingleStore. So it's definitely possible, and I encourage you to spin up our cluster and check with our team, see how we can help you if you're considering that augmentation or modernizing of your data stack. Well, this has been our meetup on distributed SQL technology with SingleStore. As you're continuing your learning journey, I'd like to encourage you to check out training.singlestore.com. I'd like to also encourage you to learn more about our company. SingleStore is a venture-backed company, and a quick history is we were Y Combinator 2011. Today, we're almost 400 employees with global offices between San Francisco, Seattle, Raleigh, North Carolina, Lisbon and London, Bangalore, Kiev, and expanding also to other regions of the world, such as APAC. And there was a question that came in about internships. SingleStore is always hiring. We hire for interns, we hire for full-time roles. We have a variety of roles available on singlestore.com/careers. In fact, for our upcoming class of interns, we have the most we've ever had. We have almost a dozen interns joining us in our engineering department. So very exciting to continue to grow and scale together. And if you're excited and passionate about our technology, we'd love to have a conversation with you. This meetup's been virtual. We're going to continue to bring meetups in person and hybrid. If you're looking for additional meetups for SingleStore, you can check them out on meetup.com. We have our SingleStore meetups available for our Raleigh chapter, our Seattle chapter, as well as our New York City chapter. So stay tuned for those meetups. And thank you everyone for joining us today, learning about distributed SQL. I'm looking forward to seeing you continue your learning journey. And starting today, it's part of the decade of data. It's modern data stacks, and excited for everyone who's learning. My name is David Yakobovitch. I'm our education delivery specialist for technical enablement here at SingleStore. And wherever you are, make it a great rest of your day.